Hello everyone, welcome back to Mana Physics Guru channel. Yes, so in this video we are going to discuss about that the most first and most important chapter, that's units and measurements. Yeah, this is also named as units and dimensions. So yes, in these units and measurements, what we are going to learn? First of all, we'll give the overview of physical quantities and their units. Physical quantities, what is physical quantity and how it will be like, and its units like SI unit, CGS unit, and that's will give. And afterwards, dimensional analysis. This is a very important. Every examination there will be one question based on this dimension analysis. Then errors and significant figures. Yeah, so like that we can divide this chapter in three particular segments: physical quantities, SI units and the CGS units, whatever related units, and dimensional analysis, errors and significant figures. Yes, let's see what is a physical quantity. Yeah, what is a physical quantity? For example, what is a quantity? As generally a quantity, we can say that a size, shape or vastness. Size, shape or vastness, that's we can say that a quantity. Generally quantities we can divide it as physical quantities. Physical quantities are which can be measurable. The quantities which can be measurable, that we can say that physical quantities. That means measurable quantities means, is there any immeasurable quantities which are not possible to measure? Yeah, let's think. Let's think which are the quantities not possible to measure. Yes, exactly, our feelings, our sadness, happiness, our love, so that we can't measure, right? Yes, which are able to measure, those quantities we can call as physical quantities. Generally, these physical quantity divided into three types. Physical quantity. Physical quantity is the quantity which is measurable. The quantity which is measurable we can call a physical quantity. The quantity which is measurable. Yes, what are the things we can able to measure? Yes, we can able to measure different things like mass, time, length, force, right? Weight, even we can able to measure the mass of earth, distance from sun to earth. These all we can able to measure. These are all comes under physical quantities. Yes, in that we have three types of physical quantities. First one, fundamental physical quantity, and I'll try to make as simple as possible for the writing session. If I write everything, it is going to be lag. Yes, I'll try to make it as simple as possible. First one, fundamental physical quantity. Yes, fundamental physical quantities, the physical quantities which are independent on any other physical quantities. The physical quantities which are independent on any other physical quantities. That means these are fundamental quantities which are independent on any other. Yes, total we have 7 fundamental physical quantities. 7 physical quantities we have. What are those 7? We'll clear it. Yes, those are the first and foremost one, mass. What is the SI unit of mass? Just SI, system of international unit. Why is our system of international unit? Yes, because generally in India we used to measure the mass in kgs, whereas if you are going to UK, they used to measure in pounds. In some other units, means different places they using different units. So to make it in a simplest manner, using SI unit, system of international unit, we can use mass SI unit as kg. Next, we have length. So mass, length also another fundamental physical quantity. That's SI unit we can take meter. Third fundamental physical quantity is a time. Time we can measure in seconds. No sir, I can measure in minutes and hours, days, you can measure. But there is a common unit, that is common unit, and easiest unit is second. Yes, we can use any unit. My length meters we can use in feet also. Yes, generally whatever the regular terminology which is used, that is slightly different in system of international unit. No, just like for example, when we want to calculate area of a particular area, means your land, area of your land. Generally, if it is agriculture land, we used to measure in acres, right? If it is a construction land, we are using for commercial purpose. Yeah, what we are using? Many things. Some areas used to say that gajam, ads, square ads. Some areas used to say that cent. Some areas used to say that gunta. Some areas used to say that ankanam. Whatever different units we have. Whatever it. Here we are going to learn the fundamental physical quantities: mass, length, time, amount of substance. Amount of substance, nothing but it's like amount of substance. You can see the quantity of liquids, how much amount of quantity of liquid is there, and quantity of fluid especially like gases we can measure in as well as amount of fluid. So that's we can take as a mole. Fluids means liquids and gases. Liquids we can measure in liters. Yes, obvious. Amount of substance. And then luminous intensity means nothing but light. Luminous intensity. This unit is candela. Candela is the luminous intensity unit. Next, amount of substance. Electric current. We have electric current. Electric current also one of the fundamental unit, and that's we are using ampere. And temperature. Temperature also a basic unit. That unit of temperature we can take Kelvin. Kelvin. Yeah, you have seen that. We have some fundamental physical quantities, total 7: mass, length, time, amount of substance, luminous intensity, electric current, and temperature. What is the meaning of these? Which are independent on any other physical quantities. Which are independent on any other physical quantities. It is only depends. Yes. So by the part we can write the dimension formula for it. What is a dimensional formula? Dimensional formula which is used to represent a physical quantity means I have mass is kg. I have length is meter. If I have area SI unit meter square. So to represent that, we have to represent meter square. That means we are raising its power. So that raising its power, to represent any physical quantity, we can raise its power by the given value. That's we can call as a dimension. We can discuss deeply in dimension session. So in this condition, just I am writing the dimensional formula for this. So in that you can see the first mass we have. Mass first letter M. So its dimensional formula is we are writing, and its dimensional formula is M. We can write capital M. That's all. M1, L0, T0. This we can say the dimensional formula of mass. Next, length. Length first letter actually capital L. So here we can write M0, L1, T0. Time M0, L0, T1. Sir, why this M0, L0? Just actually mass, length, time are the basic fundamental units. To represent that, we are using this. Mole power 1 we can write. If it is mole square, you can write mole square. Candela, CD power 1. Some areas you can find CAD also. Ampere, I or A dimension we can write. Kelvin, K. Temperature, Kelvin. So K1. I, current or ampere, candela. So these are the fundamental physical quantities and its dimensional formulas. Yes. We'll move to next, derived physical quantities. We said total 3 types of fundamental physical quantities we have. 3 types of fundamental physical quantities we have. In that, a second one is derived physical quantities. In the name only we have derived, means we are going to derive these physical quantities from other physical quantities. So these physical quantities derived from fundamental physical quantities. The physical quantities which are derived from fundamental physical quantities we can call derived physical quantities. The physical quantities which are derived from fundamental physical quantities. Yeah. What are those? And how many? Means actually I told already there are 7 fundamental physical quantities only. But how many derived physical quantities? There is no particular number. There are many. Many means in 2 years nearly you can find in 11th and 12th 2 years. You are going to find means in first year, second year nearly you can get 300 more over that. Maybe yes, nearly 300. But these many we are going to derive now? No. If we are deriving the 300, this video is going to be 5-6 hours of length. Yes, we can go with a important and as well as some basic things which are we are using in derived physical quantity. Yes. So we'll write derived physical quantities and their formula, how they are defined, and their SI unit, and if it is possible their dimensional formula. We'll see that. Yes. First one I am considering area. Area we can write the formula of area. Yes, side square means length square. So what is the SI unit for length? Already we told meter. So that's why this will be meter square. So meter square, length first letter L. So that's why this we can able to write L square. Sir, I can write M0 L0. Sorry, M0 T0. Yes, you can write. Sir, I will not write M0 T0. You don't write. Good. No problem. Yes. Next. Volume. Volume means volume only. Means cube. What is that? If it is cube, length cube. No sir, I have sphere. If we have sphere, 4 by 3 pi r cube. R cube. R is nothing but radius, distance. Cube only. No sir, I have a cylinder. Yes, pi r square h. R square length, h length cube. Finally, whatever the body. Okay na? Yes. So that's why SI unit is meter cube. Dimensional formula is L cube. Okay na? Yes, you can write M0 T0 or you don't write M0 T0. No problem. But M, L, T are the basic fundamental units. Next. Density. Immediately density. Why? Why? Because I have volume over here. Density is equal to what we can write? Mass by volume. Mass by volume means I can write density is equal to m by, yes, v. Mass unit we have kg per meter cube. Volume per meter cube means I can write a meter inverse means minus 3 power minus 3. Yeah, nothing but here mass we have how much 1 m1, and length how much? L minus 3. T not there, but you can write T0. Okay, area, volume, density. Done. Done. Next, fourth one, speed. Speed is nothing but, yes, you can give distance by time. Distance by time. Distance S by T. Distance nothing but length. Length nothing but meter. And time inverse. Meter per second you can say that. Meter per second. Meter per second you can say that. Per second. Yes. What is the unit? M1. L0. Wrong here. M is not M. M is mass. So that's why M0, L1, T minus 1. L for M here meter means length. S is second, time. Velocity, same, displacement by time. Nothing but speed and velocity are having same dimension. Speed and velocity. Speed, velocity. Formula, displacement by time. Displacement is nothing but length. So same SI unit, same dimension. But other properties are different. Yes, one is vector, one is scalar. What is scalar, what is vector? We will get. Yes. Next, acceleration. Acceleration in the sense change in velocity upon time. Change in velocity upon time. Velocity unit we have meter per second by second. So that's why this unit is meter per second square. Meter second inverse. Yes, minus 2. What is the dimensional formula? Mass is there? No. This mass is not mass. That M is meter. So that's why M0, L1, T minus 2. M0, L1, T minus 2. Acceleration. Yeah. Next. Acceleration is there. Mass. So I will write momentum. Momentum is equal to mass into velocity. Mass into velocity. Momentum P is equal to mass into velocity. Mass kg, velocity meter per second. Meter per second. Kg meter per second. So what is the dimensional formula? Mass M1, length L1, T minus 1. M1, L1, T minus 1. That is the dimensional formula for momentum. Yes. Now, force. Force, what is the formula? Force, we know that mass into acceleration. Mass kg, acceleration meter per second square. What is the dimension? M1, L1, T minus 2. M1, L1, T minus 2. That's the dimension of force. Yes. Next, pressure. What is, you can observe here in this all 7 or 8 physical quantities, any physical quantity is independent. No, Each and every physical quantity depends on others. See, area depends on length, volume depends on length, density depends on mass and volume, speed velocity depends on distance and time, displacement and time, acceleration depends on velocity and time, momentum depends on mass and velocity, force depends on mass and acceleration. So that's why these are all we can consider as derived physical quantities. Yes. Next, pressure. Pressure is nothing but a force by area. Force formula what you wrote, mass means here dimension you can see kg meter per second square by area meter square. Nothing but this will becomes kg meter inverse second inverse. So the dimension of the pressure is m1 L minus 1 T minus 2. M1 L1 L minus 1 T minus 2, that's the dimension of pressure. Yes. Next, work. Work is nothing but we can say that force into displacement. Force into displacement. Force, already we wrote kg meter per second square. Displacement meter, nothing but kg meter square per second square. But it's not SI unit. Here force also SI unit is Newton. Newton. Pressure SI unit is Pascal. Yeah, we will discuss it. And work SI unit is Joule. But we can write for the dimensional formula like this, kg meter square per second. Yeah, this becomes m1 L minus L2 T minus 2. Yes, this is the dimension of work. And also we have energy. Energy, you know that very famous equation, equal to mc square, m mass, c speed of light. Yeah, kg meter per second whole square, nothing but meter square second square. What is this SI unit again? Joule. That means what you have observed? Yes, both energy and work are having the same unit. Both and energy are having the same unit. Yes, energy. And we can also give power. How many are there, sir? Many are there. I told you na. There are nearly 300, 350, 400 physical quantities in physics we are going to study. Yes. But how many we will write means there is no limitation, but we will write some more. Yeah. P is nothing but power. Work done per unit time. Work by time. Work already you wrote kg meter square per second square by time second. Nothing but kg meter square per second inverse. So this is the dimension m1 L2 T minus 1. So this is the dimension of power. So like that we can write many dimensional formulas based on this. Right. Next, supplementary physical quantities. Third. So first one, fundamental physical quantity. Next, derived physical quantity. Now we have third one, supplementary physical quantity. Supplementary physical quantities. How many are there? Yeah, see, first 7 are there. Next nearly many are there. This is also many. No here. Here only we have 2 physical quantities only. There are two physical quantities, two supplementary physical quantities. Actually, I am searching for a paper. Yeah. So, what are those? It is look like a rectangle. What is the angle here? What is the angle in this rectangle? Not this. Yes. This angle. Yeah, we know that. Angle 90 degrees. Right? Here also 90 degrees. If I made something like in the form of triangle. Yeah, if it is right angle triangle. Yeah, what must be the angle? Somewhere 45. If it is square, the angle will be 45 other than something. Yeah, we can say that directly. Right? But now if I convert into a cone, what is the angle here? What is the angle here? Cone. Yes. So actually here we are going to discuss about two things. One is plane angle and other one is solid angle. Plane angle and as well as solid angle. Plane angle is nothing but in plane, whatever we are considering in plane sector. Yeah, we will discuss it deeply and detailedly. Yes, I can take the circle. What is the angle here? We can say that this angle is 90 in a sector. What is the angle in case of a square? Yeah, this angle is 90. We have an equilateral triangle. What will be this angle? 60. Yeah, we can say that particularly 90, 60 or something 36, 72 like the different angles. So these angles we can call as plane angles. These angles we can call as plane angle. Plane angle, what is the SI unit for it? Yeah, this SI unit is radian. We can say that SI unit is radian. Is it having dimensional formula? No. Why? Because angle derivation, we can give theta. This is arc length, radius. Angle equal to what you can write? Arc length by radius. Arc length by radius. Arc length, length meter. Radius also meter. So what is the dimension? What is the unit? It's not having that. Yes. So that's why this is a dimensionless. Dimensionless physical quantity. Plane angle is a dimensionless. Sir, you said here 90 degrees, 60 degrees, and here you are writing radian. Yeah, there is a relation. We know that pi radian is equal to 180 degrees. Pi radian equal to 180 degrees. Nothing but 1 radian equal to, yeah, 1 radian. Plane angle and the second one is solid angle. Solid angle. Solid angle generally we measure in cone. Yes, angle in the cone. So this angle, this particular angle, we can say that a solid angle. What is the SI unit? We can write steradian. Steradian is the SI unit of this solid angle. But how to represent the solid angle? Yes, we can write solid angle is equal to surface area. Surface area is something a small area by surface area by its radius. That means square, radius square. So this we can take as a solid angle. Solid angle generally measures in 3D objects. For 2D objects we can take plane and for solid angle we can take 3D objects. Yes. Next, unit. We just completed that physical quantities, fundamental physical quantity, derived and supplementary. Next, we'll talk about unit. What is a unit? Unit is a standard measurement of any physical quantity. Is it really unit is important? Yes, of course. If I went to a shop to get some groceries, yeah, I need some rice, sugar, or some wheat, or something. How I can able to ask? If I went and ask, give some rice, is it possible? Yeah, 100% he will ask a question. How much? How much you want? I need some oil. How much you want? I need something so and so thing. Yes, how much? And you are planning to travel somewhere. For example, you are planning to travel to Delhi. Yes, your first question you ask, how much distance it is from here? Yes, in that, the unit plays very important role when you are measuring it. Unit is a standard measurement of physical quantity. Unit is a standard measurement of physical quantity. Every physical quantity, it is having its standard unit. Yes. So that's we can write any physical quantity you can take. Any physical quantity. So that physical quantity which is having some numerical value and as well as unit. That's when we can take n into u, numerical value into unit, which is always constant. Why it is always constant? Yes, the numerical value and unit we can write n1 u1 is must be equal to n2 u2. Don't get confused. I have taken 1 meter is equal to how many centimeter? 100 centimeter. Here n1 is equal to 1, u1 is equal to m, n2 is equal to 100, u2 is equal to centimeter. Did you get? Yes, of course. N, numerical value, u, unit. The sum of numerical value and unit is equal to remains constant. That's only we used to write n1 u1 is equal to n2 u2. 1 meter is equal to 100 centimeter. So that is n1 u1 is equal to n2 u2. And that means a numerical value always inversely proportional to unit. If numerical value increases, unit decreases. Numerical value decreases, then unit increases. Yes, that's the meaning of inversely proportional. Yeah, we see some system of units we have in that. What are the units that we will see? First, generally we can take basic unit, mass, length, time are the basic units. Mass, length, time are the basic units. In that, what we can write in MKS system, MKS system and CGS system, FPS system and SI system. MKS, CGS, FES and SI system. MKS, M stands for meter, K stands for kg and S stands for time. So that's why according to that we will write. Yes. Length, mass. Length, yeah. In MKS system, the unit of length is meter. Unit of mass is kilogram, kg. Unit of time, second. In CGS system, unit of length is centimeter. Unit of mass is gram. Unit of time, second again. In FPS system, So we can mention feet or foods, actually we can say that. Pound, second. In SI, meter, kg, second. Meter, kg, second. So this is the generally unit we can measure in different system of units. MKS, CGS, FPS and as well as SI. Length we can measure meter, centimeter, feet and meter. Mass, kg, gram, pound, gram. No, sorry, kg. Time everywhere second. Yes. And why this MKS is similar to the CGS? Means it's not always. Some units, for example, you can take a force. Force SI unit we can write Newton, but force CGS unit we can write, sorry, SI unit we can write Newton, MKS unit we can write kg meter per second. Kg meter per second. Like energy, joule, and some other unit we can write. Yes. We can see that uh, energy and some other functions. Some other functions we'll see. For example, energy, if we are writing energy, energy we can write SI unit is joule, but MKS unit is kg meter square per second square. Kg meter square per second square. Yes.
Okay, students, this is the class in this physical quantities and fundamental derived supplementary physical quantities and system of units we have discussed. We'll continue in the next class with the dimensional analysis and how we can able to use that. Please subscribe. Thank you.